Welcome to This Explainer. We're diving straight into the absolute biggest frustration developers face when dragging AI agents out of a shiny, perfect demo environment and throwing them into the messy reality of production. We have all been there, and today we're going to fundamentally rewire how you think about your agent's brain. Picture this. You've built a gorgeous travel assistant. It's snappy, it's working beautifully. But then, it happens. Your AI agent just booked a non-refundable flight for the wrong city. Why? Simply because it completely forgot an instruction you gave it just 3 messages ago. It is unbelievably frustrating when your agent seemingly drops basic parameters, right? It tanks the user experience, it can literally cost real money, and honestly, it just makes the AI look broken. But hey, here is the good news. This isn't because the AI is dumb, and it's not a prompting problem at all. It's actually an architectural flaw. In this explainer, we're going to uncover the brilliantly simple, often 3-line fix that gives frameworks like LangGraph or CrewAI real permanent memory. Get ready to stop endlessly tweaking your prompts and start building actual robust infrastructure. Section 1. The Goldfish Agent Problem. Let's look at why the agents we build tend to act like goldfish the absolute second they hit the real world. In a demo environment, conversations are naturally short. Everything you say fits perfectly, snugly inside the model's context window. The agent looks brilliant because all the info it needs is right there in front of it. But in a production environment, conversations run long. A user steps away, they come back the next day. You inevitably hit token limits. Older messages just fall off a cliff and truncate. And suddenly, your agent loses track of what was already decided. It literally has zero idea who the user is anymore. Section 2. Context is not memory. To fix this massive missing infrastructure problem, we have to shatter the most common illusion in AI development. The context window is not memory. This is the crucial paradigm shift you need to make right now. It feels like memory, sure, because your agent can temporarily recall what you said a minute ago. But here's the secret. Your agent never actually stored a single thing. It was just rereading a temporary transcript back to itself. And the second that token limit runs out, that transcript goes straight into the shredder. Section 3. The 3 memory layers. Okay, so if the context window isn't memory, what is? Well, real agent memory actually lives completely outside the model. Let's break down how a proper brain is architected. First, you have your working memory. That's your context window. It's still useful, but only as a quick scratch pad for the immediate task right in front of it. Second, you have your episodic memory. Think of this as a secure record of past interactions stored away in a database or a vector store, which only gets pulled back in when it's highly relevant. And third, you have your persistent state. This is where you lock in structured facts about the world or the user that shouldn't have to be rediscovered every time. Think of a user's strict preference for metric units, or the fact that step 3 of a complex workflow is already checked off. Section 4. LangGraph and CrewAI fixes. Now that we know what memory actually looks like under the hood, let's make this super concrete and see how it builds into real applications. Say you're building a multi-session trip planner in LangGraph. Without external memory, every single session starts from 0. But with LangGraph checkpointing, you just attach a simple checkpointer like a SQLite or Postgres saver directly to your graph. Every state update automatically persists, and it's keyed to a unique thread ID. This means the next time that user logs in, you use that exact same thread ID and bam, the session resumes exactly where it left off. The destination and budget are already firmly set in the structured state. You aren't desperately stuffing old chat messages back into a prompt, you are loading hard facts. Now, what if you're using CrewAI instead? The implementation is a bit different, but you get the exact same powerful result. While LangGraph loads structured state directly into the graph via those checkpointers, CrewAI rocks a unified memory API. This API automatically categorizes data for your crew of agents. It juggles short-term tasks, handles long-term insights across runs, and crucially, it maintains entity memory. That means it tracks specific facts about people, places, or preferences, so your agents don't have to constantly relearn who they are talking to. Here is the absolute golden rule across the board. Do not rely on the context window as your database. Just don't do it. The practical pattern across any framework you choose is identical. You must write key decisions, task progress, and user preferences to real persistent storage. Stop blindly crossing your fingers and hoping these vital details somehow survive in a temporary chat history buffer. Section 5. The Selective Retrieval Rule. Hold on, though. Before you go saving literally every keystroke to a database, you have to accept a pretty hard truth. Memory isn't free. More is definitely not always better. Dumping your entire stored history back into every single prompt you send to the LLM is a spectacularly terrible idea.
Not only does it burn through expensive tokens like crazy, but it actively confuses the model by overwhelming it with totally irrelevant context from 3 weeks ago.
The developers who really get this right completely avoid that lazy dump everything approach. Instead, they use what we call token-optimized retrieval. Rather than retrieving every random fact you've ever stored, you deliberately pull back only the 3 or 4 highly relevant facts that actually matter for the specific step the agent is taking right at that moment. This keeps your agent remarkably sharp, incredibly focused, and highly cost-effective. This whole what actually matters right now puzzle, that's exactly why we're seeing the massive rise of dedicated memory layers, like Memo. Memo is built to sit right on top of frameworks like LangGraph and CrewAI. Its entire job is to automatically handle that token-optimized, selective retrieval for you. It ensures your agent gets exactly the context it needs, right when it needs it, without drowning in its own historical data. All right, let's bring it all home. To recap this explainer, first, you absolutely have to stop treating the context window as memory. It's just a temporary buffer. Second, real memory means persisting structured state outside the model entirely. Third, rely on robust tools like LangGraph checkpointing, CrewAI's Memory API, or dedicated layers to handle all this persistence. And finally, use selective retrieval to pull back only the relevant facts. Keep your agent focused. So, take a really hard look at your architecture today. Ask yourself, is your agent still acting like a goldfish, treating every single user like a total stranger? Or are you finally ready to implement these 3 layers and build an AI that actually remembers? The infrastructure is right there waiting for you. It's time to put it to work.